All right, in this chapter, we're going over the interior of the Earth, what the layers are, compositional and mechanical, and how we know what is inside the Earth. So the first thing I'll start off with is the layers of the Earth, and I'll do the compositional ones first. The compositional just means what exactly it's made of. There's three different kinds. We first have the crust. That's on the very outmost layer. This one is made of lots of silicates. It's very light. It's all the rocky stuff that we see on the surface. Pretty easy. Next one is the mantle, which is right below the crust. It's made up of oxides, things that are bonded to oxygen. And then lastly, we have our core, which is made up of iron. This is all pretty simple, not too much to think about. Then the thing where it gets a little tricky is with our mechanical layers. Mechanical is how they react to forces and such, like if it's more solid or more liquid or something else. And there's 5 of these. Our first one is called the lithosphere. Lithosphere is just where the crust is. It's very similar. It's everything right on top, everything we're walking on. It's very rigid and solid. And we can see that. We see our mountains. They're very solid as well, made up of a lot of rock. Our next one is the asthenosphere. Our asthenosphere is what drives our plate tectonics. It's very plastic in nature is what we like to call it. You can equate it to a consistency like silly putty. The lithosphere rides on top of this asthenosphere and makes the continental plates crash into one another. Next, we have our mesosphere. The mesosphere is completely solid, and the mesosphere is actually where we get a ton of our magma. Once it comes up from the mesosphere layer, it turns into magma because of the less pressure. And then we have our core, which is comprised of 2 different things. We have our outer core, which is a liquid iron layer. It's convecting and moving around, and it causes actually a magnetic field in Earth that we can see. And then our inner core, which is completely solid. So that's our mechanical and compositional layers. So how do we know that all these things are there? There's 5 different evidences that tell us this. Our first one is observation. By observation, you can look at the rocks on the ground. You have magma coming up from the mantle and the mesosphere, and then you can also dig a hole. They actually dug a hole in like Russia, and it was about 8 miles down, I want to say, but that's all the deeper we can get. It's really hard to dig through the crust. Second, you can check the mass and density of the Earth. Through a series of equations with physics and everything, we've been able to calculate the mass of the Earth without actually putting it on a scale, and then calculate the density. So the density of Earth is about 5.5 grams per centimeters cubed. And then what we see on the Earth's surface is about 2.7 density of all those silicates, those very light materials. But through all of our calculations, we noticed that the actual density of Earth, or the average density, is about 5.5. So from that, we can assume that there's something heavier within the center of the Earth that we can't see. You can look at meteorites. Meteorites in our solar system were formed about the same time that our Earth was. So if we get meteorites coming from, of course, out in space, we can see where, or what started the accretion of Earth. Also, we have iron meteorites that come from differentiated bodies, or planets, and we can see from those that, since we can't see it on our Earth and everything was formed in the solar system at the same time that Earth was, that we must have iron in our planet as well. Next thing is seismology. So seismology deals with earthquakes and everything that goes on with them. So there's 2 different kinds of waves that happen when there's an earthquake. There's S waves and P waves. S waves we know are shear waves, and they can only travel through solids. P waves can travel through everything. So if we have our model of the Earth, here's our core, there's everything else. If we have S waves going on through, we have this thing called a shadow zone down here, that there's no earthquakes, we don't feel any sort of vibrations whatsoever. It's because we have our outer core here that is liquid. And since S waves can't travel through solids, we assume that this is made out of liquid. That's where we get that. And then if we have P waves, we have refraction that goes on in the core. Because we know that from our unit with waves, that when things go through different mediums, they refract. And so when it's going from a solid to a liquid, it refracts, causing even more shadow zones, which gives us more evidence that there's some other state of matter within the center of the Earth. So our last thing is magnetism. Magnetism, we can see it on the Earth through compasses, by things being able to point north, and also by instruments we're able to see our huge magnetic field. The thing that causes a magnetic field this big is iron convecting. So we have a convecting iron layer in the middle of the Earth. All right, and with that, that is the end of this chapter.